Good morning. We are ready for section 13.4. We're going to be talking about circles, triangles, and three-dimensional shapes. All right, so one very common shape that doesn't have straight lines and thus is not polygon is a circle. There you have a circle at the bottom of your page, 263. It shows you the center. So a circle is a closed two-dimensional figure. Each part of the edge is equally distant from the center. Another way to think of a circle is as the set of points in a plane that are equivalent from a given point. If you have a compass, try drawing a circle. A compass like the one pictured there on the right on 263, one of those that helps you draw one. If you have one, you can practice on drawing them. If not, that's okay. Basically what you do is you put the pointy end of the compass on a piece of paper, and then you rotate the end with the pencil around it. Every point on the circle would be equally distant from the point where you place the pointy end of the compass. We use circles to represent many different objects. If you look around your house for objects circles can describe, you might be surprised how many you find. Circles and the relationships between the parts of circles also help us describe various aspects of creation, including gravity. Let's look at triangles. As we saw in the last lesson, triangles are polygons with three sides. As we continue exploring shapes, we'll discover that triangles help us describe many different and often unexpected aspects of the world. For example, triangles can be used to describe portions of other shapes, as well as the height and the slope of mountains. In fact, back in the 1800s, the geometry book of the time was called geodesy, and it taught readers how to survey. Triangles were a big part of it. In more roundabout way, triangles even help us describe sound waves. So not surprisingly, we have names for triangles with different characteristics, just as we did for quadrilaterals with different characteristics. We subcategorize triangles different ways based on our needs. So here's some things you're probably going to want to write down in your notes if you have those. Now, we have triangles categorized in two different ways. You can categorize them by their length of their sides. If you do that, you have isosceles, equilateral, or scalene. Now, an isosceles has two equal sides. An equilateral has all equal sides. And a scalene has no equal sides. Okay? So that's one way you can categorize triangles. If you do it by their length of sides, and those are the three different named ones, you really want to write that down. Then you can also categorize triangles by their angles. Okay, there's a triangle with a right triangle because it has a right angle. Then you have an acute triangle. Remember, that's a cute one because all of the angles are smaller than a right angle. Or you can have an obtuse triangle where it has one obtuse angle. Every triangle can be categorized by both sides and angles. So you'll often see these terms combined. So at the very bottom of 264, you have an obtuse scalene triangle. What that means is it's a triangle that has one obtuse angle and none of the sides are the same. Or you can have a right isosceles triangle. Okay, so you have a triangle that has one right angle and two equal sides. That's a right isosceles. And those are just examples. Now for the purpose of, I'm on top of 265, for the purpose of this course, whenever you're asked to identify a triangle, you should use as many names as you can unless you're specifically told otherwise. So whenever it says, name this triangle, okay, if it'll have two names in front of it. It'll be one categorized by the length of sides and the other categorized by the angles. But generally, I think we name the angles first and then the sides first, if that makes sense. So it would be acute equilateral, or it would be right scalene. Okay, all right. Now, To label triangles, just as we can use letters to label lines and angles, we use letters to label triangles. So there's a triangle. They've labeled each end ABC. So the triangle is triangle ABC. And that's how you read it. Make sense? Now, I'm assuming it could be ACB as well, but they just did ABC. You'll just put a little tiny symbol of a triangle in front of it to label that triangle. All right, let's look at three-dimensional shapes right quick. Now, we often look at three-dimensional shapes as several two-dimensional shapes instead. For example, we would view each side of this toaster oven as a rectangle. Now, there are times when we need a name to describe three-dimensional shapes as a whole. So if we wanted to refer to the entire toaster oven as a unit rather than just to one side of it, we'd call it a prism. Okay, so one side of the toaster oven is a rectangle, which we know is 2D. Okay, but if you want to talk about the shape of the entire toaster oven, you would not call it a rectangle because a rectangle is 2D. So to refer to that as a shape, you would call it a prism. And this word you need to know. A prism is a polygon, which is a square, triangle, hexagon, etc., with some uniform depth. More specifically, a prism is a solid, this is the definition, a solid having two bases that are parallel polygons and faces that are parallelograms. I know that probably sounds like Chinese to you, but if you study that definition, it should make perfectly good sense to you, according to all the terms that you've been learning. So the prism is named after the shape of the bases. A prism with triangular bases is called a triangular prism. Now the base would be like what it sits on. One with a rectangular base, a rectangular prism, and so forth. So more properly, the toaster oven should be known as a rectangular prism because the base of it, where it sits. Okay, so on the next page, there's some really good pictures of right there, and you might want to even try to draw or even trace these if you can. Now, prism. There's your definition: a solid with two bases that are parallel polygons and faces or sides that are parallelograms. The prism is named after the shape of its bases, and there it points to the bases. So that first one, the bases, which are the top and the bottom, are triangles, and that other one, they're rectangles. So if you have one that sits on a triangle, it's called a triangular prism. If you have one that sits on a rectangle, it's a rectangular prism. Okay? Then you have a hexagonal prism. That means the bases are hexagons. And you have a cube. That's where the bases are perfect squares. Okay? Here's you another term. A cylinder is similar in that it has a circle with depth or height. But since its bases are not polygons and its sides are not parallelograms, it doesn't have its own special name. So we just call it a cylinder. Cylinder would be like a can or something to that effect, like a tuna fish can or a green bean can or something to that effect. I always think of an oatmeal. I love oatmeal, so I always think of a big oatmeal thing. Those are cylinders. We're surrounded by shapes. Names help us describe and categorize these shapes as well as other aspects of God's creation. Sometimes it's helpful to name just one side of an object, such as the front of the toaster oven, while other times that we need to name the entire object. Always remember that shapes are tools to help us explore God's creation, tools that we can use while praising the Creator. Let everything that hath breath praise the Lord. Praise ye the Lord. Psalm 150, verse 6. Awesome. All right. So your assignment then is going to be worksheet 13.4, but be prepared because it's actually 3 pages long. Okay? So you should do well. I mean, it's just going over what we just talked about. Anytime, if you need help on any of that, obviously let me know. And you can also look back in the book. But there are a lot of skill sharpening pieces in here today. So I think I'm just going to grade the skill sharpening. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll probably make this worth 10 points. and grade just 6A through J. Okay, and that'll give you a grade on those things. Anyway, if you need any help, let me know. Otherwise, that's all for today.
Yeah!